Hi, my name is Astrid Modi and I'm from the design school Kolding in Denmark, and I will present the OER Scaling Textiles, which is a part of Block 4 prototype. Let's start with the introduction. This OER aims to provide students within higher education with a better understanding of the parameters that define the experience, visual, tactile, and structural of a textile surface, and how systematic changes of these parameters influence the experience. A better understanding of these parameters is important when developing textile prototypes using advanced technology. One thing is understanding the technology, but even more important is that the students understand the criteria they can design with. Especially when acknowledging that textile technology, also advanced textile technology, originates from craft that is industrialized. Many of the products we produce on machines today could also be made on hand looms or even small frame looms as applied in this activity. Consequently, this activity provides students with basic hands-on understanding of the parameters that define a textile surface, how they can be investigated and modified in prototypes, how students can learn from prototypes, and how prototypes can help them to evolve a design. This is valuable and necessary craft-based knowledge that then can be applied in advanced textile technology. In the activity, each student group will investigate following board inquiry. How is the experience visual, tactile, and structural of a simple woven structure influenced when changing thread, thickness, and type of weaving? By constructing 3 different weaving techniques, a plain weave, a Panama weave, and a twill weave. Each technique will be woven with a cotton cord of 4, 6, and 8 millimeters. That means, as a result, each group will construct 9 woven structures, a plain weave using a 4 millimeter cord, 6 millimeter cord, and 8 millimeter cord, a Panama weave using a 4, 6, and 8 millimeter cord, a twill weave using a 4, 6, and 8 millimeter cord. As a practical advice, we advise groups consisting of 3 students each. We further recommend that 1 student of each group is responsible for 1 weaving technique, and that you start with the 8 millimeter cord. Let's take an example. Group 1 consists of student A, B, and C. Student A is responsible for the production of 3 plain weaves, starting with 8, followed by 6, and concluding with the 4 millimeter cord. Student B is responsible for the Panama weaves, starting with 8, followed by 6, and finally using the 4 millimeter cord. And student C is responsible for the production of 3 twill weaves, starting with 8, followed by 6, and concluded by 4 millimeters. This OER is structured in 4 sections, starting with goals, followed by a background section, followed by a terminology, followed by a presentation of the activity. Keywords of this OER are textiles, weaving, textile logics, scaling, architecture, and industrial design. This OER has a primary and a secondary goal. The primary goal is to provide design disciplines with another background than textile design, with knowledge and hands-on experience of the design parameters that define a textile surface and how innovation potentials they can offer within their discipline when using advanced textile technology. The secondary goal is to nurture examples, prototypes, and methods that can inspire others to cross-disciplinary cooperation across textile design and architecture or industrial design. Learning outcomes are defined in terms of knowledge, skills, and competences. Students will get an understanding of textile properties, techniques, and logics, and how the interplay of these influences conceptualization of and design with textiles combining function, form, and aesthetic expression. They will also get an understanding of the potentials and limitations of weaving. In terms of use, they will use concepts, procedures, and methods for working design-led and practice-based with textiles through hands-on experience. They will make prototypes that are comprehensible and transparent for others to allow them to learn from failures or to transfer knowledge from one context to the other. In terms of competences, they will learn how to transfer doing and thinking from one discipline to another to foster cross-disciplinary cooperation. The activity is removed from the complexity of application. Through decontextualization, the OER aims to provide students with a better understanding of textile techniques, their aesthetic expressions, structural properties, and application possibilities. Constructing the 3 different weavings will demonstrate to students how the binding co-defines the aesthetic expression, how changes of thickness of the material base change tactility, and how the combination of binding and core thickness influences the functional properties of the construction. Let's come up with an example. A plain weave is usually characterized as defined and firm, while a twill weave packs the yarns tighter, giving a more narrow construction with diagonal stretch and a soft drape. Terminology. Weaving. Weaving can be defined as 2 systems of yarn interlacing at 90 degrees into each other, warp yarns in length direction and weft or filling yarns in width direction. Plain weave is the most simple woven construction, where weft and warp are crossing each other. Panama. 2 threads of warp are followed by 2 threads of weft. Twill. Twill is a type of textile weave with a pattern of diagonal whips. The use example is a 2x2 twill. The offset of each row forms the diagonal pattern. Self-edge is a self-finished edge or piece of fabric which keeps its form unwavering and fraying. Textiles are described by the English architectural researcher Mark Garcia as textile originating from Latin textere, meaning to weave, connect, or construct. Textile logics defines a conceptual framework concerned with the development of new structural models and concepts for architecture, learning from the use of theories of textile technology and textile techniques. Key protagonists of textile logics are Philip Beasley, Johan Bethune, Mette Ramsgaard-Thomsen, and Lars Sproulbrück. Draft or binding. Weaving techniques are represented in bindings or drafts. A weaving draft is a graphical representation how weft and warp interlace. Activity. How is the visual, tactile, and structural experience of a simple woven structure influenced when changing thread thickness and weaving technique? As described in the introduction, each group will explore a broad question by constructing 3 different weaving techniques: a plain weave, a Panama weave, a twill weave. Each technique will be woven with a cotton cord of 4, 6, and 8 millimeters. In the following slides, we'll work as a step-by-step guide through the activity. The guide is structured into following sections. Page 11 and 12 are define weaving. Page 13 and 14 are about preparations. 14 to 19 about the design. 20 is about reflection and presentation. 21 is presenting conclusions. And 22 and the following present further perspectives and potential contexts of applications. Weaving. Weaving can be defined as 2 systems of yarn interlacing at 90 degree into each other. Warp yarns in length direction and weft or filling yarns in width way. Here you can see the 3 bindings: Panama, plain weave, Panama weave, and hopsack. Preparation. Like in a cooking recipe, this slide and the following first present a list of materials and tools and then specify how you prepare the necessary frames before you can start the activity. You need 3 frames 20 by 20 centimeters, a cotton cord of 4, 6 and 8 millimeters, a hammer, a scissor, nails in different sizes, a pencil and a ruler. Note that the nails are offset, meaning that a nail B is positioned in the center of A and C, and that your warp threads should be tied. Do not worry about length, as you just can continue with a new thread. Here you can see the result of the plain weave using a 2, 4, 6 and 8 millimeter Panama weave. Groups of warp and weft threads are interlaced so that they form a simple crisscross pattern. Each group of weft threads crosses an equal number of warp threads by going over one group and then under the next, and so on. Start with 8, then use 6 and finally use 4. Here you can see the result. Twill weave. A twill weave can be identified by its diagonal lines. This is a 2 by 2 twill with 2 warp threads crossing every 2 weft threads. The offset each row forms the diagonal pattern. Start with 8, followed by 6, and finally use a 4 millimeter cord. Here you can see the result. While the previous slides gave a step-by-step introduction to how you produce the 9 weavings, this slide provides guidance for how to analyze, reflect, and discuss your prototypes. Start with considering visual experience, considering open and closeness, density and transparency, thickness and visual quality and associations. Consider tactility. Is your surface hard or soft? Is it strong or fragile? What are its tactile qualities and associations? Consider the structural qualities and properties of the surface. Is it strong, flexible, elastic? And what defines its durability? Take it present to each other and provide each other feedback. We suggest that you use 5 to 10 minutes per group, and that group A gives feedback to group B, etc. The key result of this OER is that students gain a better understanding of the parameters that define the experience of a textile surface and how systematic changes of these parameters influence the experience. Concretely, the activity provides students with basic hands-on understanding of these parameters, how they can be investigated and modified in prototypes, how students can learn from prototypes, and how prototypes can help them to evolve a design. This is valuable and necessary craft-based knowledge that then can be applied in advanced textile technology. As the activity is removed from the complexity of application, to allow a focus on what defines a textile surface or a design, the following slides show how learnings from this activity can be further developed within different fields of application. Here you can see some future perspective in terms of product design. This slide provides some inspirations for further investigations within furniture design. Here's some more inspiration in terms of furniture design. Here on this slide you can see some future perspective in terms of interior architecture. The slide shows different examples of textile space dividers. Here you can see some inspiration in the context of architecture, how textile techniques can be the point of departure for architectural facades. This slide is an example of how textile techniques or textile objects can be inspiration for spatial structures within architecture, and here how textile techniques or technologies can be the point of departure for spatial constructions within art. Thank you, that's it.